Hi, in the last video, I discussed about the very basic introduction of the series, okay? And then we also talk about the partial sums of a series and then the sequence of partial sums. And if you want to find out the sum of a series, then we find the limit of the partial sum. That's one way, right? So that's the definition. So if the limit of a partial sum Sn converge to a number, then that is same as the sum of the series. That's what we discussed, okay? And we did some example. Also, we introduced the geometric series. That means that the series where the ratio of the successive terms is same is called the geometric series, and that ratio among any two successive terms, if they are equal, we denote that by r, and it is called common ratio, okay? So in the geometric series, if the common ratio is less than 1 or greater than -1, what that means, if the common ratio is between -1 and 1, exclusive, meaning that excluding the -1 and 1, if all the common ratio, if any geometric series has common ratio between -1 and 1, then that geometric series converges, and the geometric series has a finite sum. That's what the converge means, right? Finite sum, and then that sum of that value is a over 1 minus r, okay? A over 1 minus r, that is the sum, okay guys? So the next thing we want to do is, so sometimes it may be harder to find out how much is the sum, but you may be interested only if the series has a finite sum or not, meaning that if the series converges or not, okay? Sometimes it is easy to see if it is diverse. It is easy to see with certain method or certain formula, okay? That's what we are going to do the test for divergence. If the summation an converges, then limit n tends to infinity, an equals to 0, meaning that if a series converges, then it's the limit of the nth term must be 0. It doesn't say much, because if you know that it converges, if you know that a series converges, then its nth terms has a limit 0. But it doesn't say, but first of all you need to know it converges, then you can test that. But we will see. And also in this theorem, the converse may not be true, meaning that if the nth term is 0, it does not imply that the series converges. But what does it imply is, that's the very important theorem that tells you if the series diverges or not, okay? If the nth term of the series is not 0, then the series always diverges. You see that? If the nth term is 0, it does not imply that the series converges. But if the series converges, nth term is 0, the limit of the nth term is 0. But if the limit of the nth term is not 0, then the series always diverges, okay? If the limit of the nth term is not 0, then the series always diverges, okay? The series diverges. So that's a very, very, very important result that we can use to see a series diverge, okay? So let us do some examples on this exercise. I will pick the examples from the book, okay, on this section. So let us do number 1. So what are the strategy to check the convergence or divergence of a series? So the easiest one is, if you know the formula for Sn, if you know the formula for the partial sum, then you can take the limit of that partial sum and then do that. But usually we don't calculate the formula for the partial sum, because it may be harder to do that, okay? So look at that, the nth term of the series, okay? If the nth term of the series is not equals to 0, if the nth term of the series not equals to 0, then the series diverges, right? If the limit of the nth term of the series, if the limit of the nth term of the series is not equals to 0, then the series diverges, okay? And also another strategy is, you can see if it is a geometric series, okay? In case of the geometric series, if the common ratio is outside -1 and +1, okay? If the common ratio is not between -1 and +1, then the series diverges. Okay, in case of the geometric series. So if you know that it is geometric series, check the common ratio. If you don't know if it is a geometric series or not, then look at if the nth term of that series is 0 or not. If it is not 0, then it diverges. Okay, look at this example now. This is example number 12 from the book. It says summation n equals 0 to infinity 4 times and then -1.05 to the n. Is this a geometric series? Yes, because it is like it is like r to the n, right? So it is a geometric series with common ratio r equals to absolute value of r is how much? It is greater than 1, right? Absolute value of r is greater than 1. That means, so absolute value of r is absolute value of -1.05, which is 1.05, and this is because when you take the absolute value, you get rid of that negative sign, right? So it makes positive. So 1.05, which is greater than 1. Since the common ratio is greater than 1, then the series diverges. This is one way. Another way is, what is S of n here? If you want to use the divergence theorem, what is S of n? So the S of n here is basically what? So here S of n is equals to 4 times -1.05 to the n, right? Is just the limit when n tends to infinity, what happens? If n tends to infinity, an does not go to 0, right? Because it is going to almost negative infinity, right? If n is positive, negative infinity. If n is whatever, for whatever reason, it will be it is going to negative. It is going to negative infinity, so it is not going to 0. You see that this is not going to 0 when n tends to infinity. We can say, so it may be negative infinity or positive infinity. Okay, depending on n is even or odd. Okay, so here when n tends to infinity, limit n tends to infinity, limit n tends to infinity, an is not going to 0 at all here, so diverges. So the series diverges. Okay, let us see that one. So is this a geometric series? No, we don't know, because it is not in the ar to the n format, right? So what do we do? Find out an. What is an? An is n over 2n plus 3. What is the limit of that? So limit n tends to infinity, an will be limit n tends to infinity, n over 2n plus 3, right? Now what is the limit here? If you plug in n tends to infinity, you will get infinity over infinity. So you can use the L'Hopital's rule. If you use the L'Hopital's rule, what do you get? 1 over 2, because find the derivative of n is 1, derivative of 2n plus 3 is 2. So is this 0, which is not equals to 0? So this series diverges, because the divergence theorem says that if the nth term has limit different from 0, then the series diverges. So that's what we got, right? Let us do question number 18 here. This is not a geometric series because there is no ar to the n format. So what is an then? An is n plus 1 factorial over 5 times n factorial. Okay, do you know what is n plus 1 factorial? Can you expand that a little bit? So what I'm going to do is I'm going to do n plus 1, okay, times n factorial divided by 5 times n factorial. That's what I'm doing here. So because what is 5 factorial? 5 factorial is 5 times 4 times 3 times 2 times 1. It stops at 1, right? So if you have n factorial, it is n times n minus 1 times n minus 2 times n minus 3 up to 3 to 1. But if it is n plus 1 factorial, I'm stopping at n factorial. You decrease by 1 and then that factorial, you can do that because there is n factorial in the bottom, so that I can cancel out. So what is left is n plus 1 over 5. Is the limit 0 here? Limit n tends to infinity, an, is that 0? Limit n tends to infinity, n plus 1 over 5, which is infinity, right? The limit is infinity here. So it is not 0. It is not 0. So the series diverges. The series diverges. Okay. In this case, what is the nth term? Nth term is 0. The series may converge or diverge, because if it is not 0, you can for sure tell that the series diverges. But if the nth term is 0, you cannot tell whether it is converse or diverse. So we'll have to use different method, or you can just find out the way that the you know the telescoping series, meaning that you can cancel. Okay, like that. All right, so let us first write down this as the partial fraction, n equals to 1 through infinity. How can you write that? You can write this as 1 over n, right, minus 1 over n plus 2. If you do that, what do you get? That n plus 2 minus n and n cancel out, 2 over that. So let me write 1/2 outside, and then so that it will balance that. Okay, so equals to 1/2. You know the partial fraction. You can do a over n plus b over n plus 2, and then do that way. You will get a is 1/2, b is negative 1/2. That's what you get. But I just did on the top of my head. If you write that, then you will get 2 on the top. To cancel that 2, I got 1/2 here. Okay, now plug in 1. N equals to 1. What do you get? If you take n equals to 1, then you get 1 minus 1/3. Plug in n equals to 2. What do you get? Plus 1/2 minus 1/4. N equals to 3. 1/3 minus 1/5 plus 1/4 minus 1/6, and so on. Now look at that. Some of these terms will cancel out, and what will survive there is, look at this. This 1/3 will cancel out that 1/3, right? And then this 1/4 will cancel out with that 1/4. 1/5 will cancel out later 1/5, and so on. So what will not be cancelled out is 1 plus 1/2. Okay, so there is 1/2, that is 1/2 times 1 plus 1/2, right? So how much is that then? So 1/2 times 3/2, that is 3/4. Yes, the series converges and the sum is 3/4, because the sum is finite number, converges, right? Converges. Okay, let us do another example. So find x for which summation n equals 0 to infinity 2 over x n converse. So is this a geometric series? Yes, it is a geometric series with a is 1 and r is 2 over x. Okay, it is a geometric series, with r is equals to 2 over x. Okay, it converges if absolute value of you can write r, absolute value of r is less than, you can write this way, either way it's the same thing. Okay, so you can write absolute value of r is less than 1. Okay, and then do 2 over absolute value of x. 2 over absolute value of x is less than 1, right? Is less than 1. Okay, so what do you get? So 2 is basically a positive number, so you don't need the absolute value, you need absolute value for x. Okay, so or 2 over absolute value of x is less than 1. Okay, so what do you get from here then? So you get, if you multiply both sides by the absolute value of x, what do you get? You get, multiply both sides by absolute value of x, you get absolute value of x is greater than 2. So this geometric series converges outside this. That is, what does that mean? That means x is because this is opposite of less than 2, right? So if x is greater than 2 or x is less than negative 2, so on that interval, on this interval, on that place, this series converges. Okay, for x positive greater than 2 or x less than negative 2, because you see that what value of x make this r less than 1? If x is bigger than 2 or smaller than negative, like if x is 3, 4, 5, 6, or if x is negative 3, negative 4, negative 5, negative 6, like that, at that time the ratio, common ratio will be less than 1, right? And then it will converge. So that's how we find out that this series converges if x is greater than 2 or x is less than negative 2. In other words, if absolute value of x is greater than 2, then the series converges. Okay guys, all right, let us see some more examples. So before I give you some example, let us see very basic rule or the properties of the infinite series. If there is one infinite series an whose sum is L, and suppose there is another infinite series Bn whose sum is k. Okay, then if there is a constant times the an, series of constant time an, you can pull that constant out and then find the summation of an and then write down that c times l. Similarly, if there is a sum or difference of two infinite series, then their limits or their sum will be sum or difference of each series there, right? So that's what it is. Now look at this. So find the sum of these two. So you can write this as equals to summation of n equals to 0 to infinity 0.3 to the n plus, you can distribute that sum, right? N equals to 0 to infinity 0.8 to the n. You see that? So what do you get there? Then this is in geometric series. This is also geometric series. So what is a here? A is 1, right? What is a here? A is also 1 here. So this is geometric series with the common ratio less than 1. This quantity is less than 1. This is also less than 1. So the formula for the sum is a over 1 minus r, 1 minus 0.3 plus this is also 1 over 1 minus 0.8, right? 1 minus r minus 0.8, right? So what do you get? 1 over, you got this as 1 minus 0.3 is 0.7 plus 1 over 0.2, right? Because 1 minus 0.8 is 0.2, right? So you get 10. This is basically 10 over 7 plus 10 over 7 plus 10 over 2, right? 5. So 10 over, so 1 over 0.7. So let's use calculator. 1 over 0.7 plus 1 over 0.2, right? If you do that, you will get 6.43. That's what you get. This is 6.43. That's what you get, right? So basically, you can find out the fractional form of this, right? So how would that look like? If you find the fraction of this, so this would look like 10 over 7 plus 10 over 2, right? So 10 over 2 is 5, right? So 10 over 2 is 5. So 10 over 7 plus 5 is what over 7? 35, or so that will be 45 over 7. That's what you get, okay, in the fractional form. All right, so let us see question number 33 from the book. It has 8 plus 6 plus 9.5 plus 27 over 8 plus 81 over 32 and so on. Okay, so I'm sure there may be many methods to handle this problem, but you see that it is a little bit tricky because you don't see that it is in the format of the geometric series right away with common ratio less than 1, because you see that this is 3 over 2 to the cubed, but that is not here. 3 over 2 is not given here, and there is 8 and 6 like that. Okay, there are terms are not given in the nicely formatted geometric series. So what I'm going to do here is let me take out 8 from all the terms, right? So what I'm going to do is take out 8 out. What is left is 1 plus 6 over 8, because there was no 8, so I divided, plus 9 over 16 plus 27 over 64 plus and so on. You don't need to write all those terms, okay? Now what is that? What is that? 8 over 6, that is 3/4, right? So basically you got 8 times 1 plus 3/4 plus this is 3/4 square plus 3/4 cubed plus and so on, right? So isn't that like 8 times summation 3/4 to the n equals to 0 to infinity 3/4 to the n? Yes, it is, because if you take n equals to 0, you will get 1. N equals to 1, you will get 3/4. N equals 2, you will get 3/4 square and so on, right? Now this is a geometric series with common ratio less than 1. So the sum is 8 times. So what is 1? A is 1 here. 1 over 1 minus 3/4. You can write like that, right? So that is how much? 8 times 1 minus 3/4 is 1 over 1/4, right? That is basically 8 times 4. That is 32. Again, so there are so many methods that you can do this problem. You can basically take 8. You can keep 8 out and then take 6 out from all of those. You can do that way too, so it will give you the similar result there. Okay, so you can do so many different ways, but this is the simplest way, I guess. Okay, But if you find some other ways, you can do that way too. All right, guys? Okay, thank you. So question number 40, find the repeating decimal of 0.63 in the fraction form. So you want to write that in the fractional form, okay? How do I do that? Let us write this one as 0.63 can be written as a bar, okay? 0.63, 63, 63, 63, 63, and so on. That's what the 0.63 bar is, okay? Now this can be written as 0.63 plus 0.0063 plus 0.006. Oh, not 0.063 plus, and so on. You see that? So if you do this, what do you get? You get, this is 0.63. Okay, this is actually 0. So this is 0.63, right? So that you can write, basically you can even write like this without, so this is 63 over 100, right? Plus, this is how much? This is 63 over 100, and then times another one, that will be 10,000, plus this will be 63 over 1 million. So 110,000 and then 1 million. So plus and so on. You can write like that, okay? Now, let us see this way. You can write this as, let us take 63 over 100 out. What do you get? 63 over 100 out. If you will get 1 plus 1 over 100 plus 1 over 100, so 10,000 plus, and so on. So isn't this same as 63 over 100 plus, not plus. So let me write. So this can be written as summation 1 over 100 to the n equals to 0 to infinity. If n is 0, you will get 1. If n is 1, you will get 1 over 100. If n is 2, you will get 1 over 10,000, and so on. So this is 63 over 100 times, it is, a is 1, right? 1 over 1 minus r is how much? 100? 1 over 100, right? 1 over 100. So that will be 63 over 100 times, this you will get 99 over 1. So 100 over 99, that's what you get. Because 1 over 1 minus 1 over 100 will be 99 over 100. So 1 over 99 over 100 is basically this fraction times the reciprocal of that. That's what you get. You cancel out. So 63 over 99. 63 over 95. That's what you get. Okay. So next, does the following series converge? So meaning that we will try to, there are two ways to say converge or diverge. One is if it is a geometric series with a common ratio less than 1. Another is if it diverges. How do we check if it diverges? If the nth term does not go to 0. Okay, let's see that. So for this one, can you write this as like summation n equals to 0 to infinity 7 times 1 over 5 to the n. You can write like that, right? Because 1 to the n is 1. That's why you can write. So this is a geometric series with r less than 1. So it converges. This converges. How about this one? This is not a geometric series because it started with 1. Okay, and also there is no common ratio because there is n to the third, right? So what I want to do is I want to find out an. What is an? An is 3 to the n over n cube. If you take the limit, so limit n tends to infinity an is equals to limit n tends to infinity 3 to the n over n cube. If you plug in limit, you will get infinity over infinity. Now you can do the L'Hopital's rule. So what is the derivative of the top? It will be 3 to the n times natural log of 3 over 3n square. Again, if you plug in the limit, you will get infinity over infinity. It will be 3 to the n times natural log of 3 to the square divided by 6n. Continue using the L'Hopital's rule. You will get 3 to the n times natural log of 3 to the cube divided by 6. Now take the limit here. If you take the limit, this goes to infinity. So this is not going to 0. so diverges. So this diverges. Again, this one, it is starting from 1. So this is not a geometric series. So what I'm going to do is write down n is secant inverse. Secant inverse and arcsecant are the same thing, right? 1 over n. So what do you get? So limit n tends to infinity, an is equals to limit n tends to infinity, secant inverse 0, right? What is secant inverse 0? It is pi over 2, right? So pi over 2, but this is not 0. If it was 0, it would, so this, if it is, I cannot say if it is 0, it diverges. So since the limit of the nth term is not 0, it diverges. If it was 0, we cannot say if it diverges or converges, but if it is not 0, it definitely diverges. That's what we can say. Okay guys, that's all for this section. Thank you.